Let's look at the particulars of what the linear pair postulate is. First of all, in order if we're going to use this postulate, we need to know what a linear pair is. A linear pair is a pair of adjacent angles, but not just any old adjacent angles. These are adjacent angles that have two non-common sides, and so this side right here and this one over here form a line. It's a pair of angles where the non-common sides form a line. Now the common side would be this one right here. And so if we were to number these angles, for example, say number 1 and number 2, we call angle 1 and angle 2 a linear pair. And a postulate is something that we know is true, and it does not require a proof. It's something that we accept as true without having to prove it. A synonym for postulate is axiom. It's something that we know is true. And when two lines cross, like this, you have four linear pairs actually. We have 1 and 2 form a linear pair. And then if I draw the 3, angles 2 and 3 form a linear pair. Angles 3 and 4 form a linear pair. And then angle 1 and 4 as well. So when two lines cross, we have 4 linear pairs to choose from. So 1 and 2 make a linear pair. And what's special about linear pairs is that those two angles will always add up to 180 degrees. Same thing here. Angles 1 and 2 have a sum of 180 degrees. And when angles have a sum of 180 degrees, we call those angles supplementary. So the linear pair postulate is the idea that if two angles form a linear pair, then they are supplementary. So let's write that down. If two angles form a linear pair, and angles 1 and 2 in my drawing above, in fact 1 and 2 in both drawings form a linear pair, and if that's true, the conclusion is then they are supplementary. And supplementary means they add up to 180. You'll see this proof box in the text on page 111. It'll be in a green proof box. And they put at the bottom, and it is a little confusing to some extent, I'll tell you why, they write measure of angle 1 plus measure of angle 2 equal 180. And we know that to be true of any pair of supplementary angles, that they have to add up to 180. But the actual postulate doesn't say they add up to 180. What it says is that they are supplementary. So in proofs in the book, you'll see the linear pair postulate being used, and it will say angle 1 and angle 2 are supplementary. Why? The linear pair postulate. And then the next step, they might say the measure of angle 1 plus the measure of angle 2 equal 180. And for that, they will require the reason as definition of supplementary angles. But it is sort of confusing because it says in the proof box that measure of angle 1 and measure of angle 2 equal 180. So in our proofs, we're going to go ahead and make it more efficient. When you see a linear pair, like we do here with 1 and 2, or in the other drawing over here, when you see 2 and 3 and 1 and 4, when you see a linear pair, 1 and 2, 2 and 3, 3 and 4, 1 and 4, let's automatically be able to say in our proofs that the measure of angle 1 plus the measure of angle 2, or the measure of those two angles, equal 180, and the reason in our proof will be linear pair postulate. That's a linear pair postulate. Again, it's found on page 111 in section 6 of chapter 2 of the textbook.